No crystal structure to distribute force. That is why glass shatters. Drop a metal pan and it bounces. Drop a ceramic plate and it cracks. Drop a glass and it explodes into dozens of sharp fragments. Every material responds to impact differently, but glass is uniquely dramatic. It does not bend. It does not deform. It shatters. The reason is hidden at the atomic level. Glass is an amorphous solid, meaning its atoms are frozen in a disordered arrangement, like a liquid that never finished becoming a crystal. That missing structure is exactly what makes it so fragile. So why does the absence of order cause glass to shatter so violently? Crystalline solids like metals and ceramics have atoms arranged in orderly, repeating patterns called lattices. When force hits a crystal, the lattice distributes that energy across billions of organized bonds. The structure absorbs and redirects the stress. Glass has no lattice. Its atoms are arranged randomly, frozen in place when molten silica cooled too quickly to crystallize. This random arrangement means there are no organized pathways to distribute force. When stress hits glass, it concentrates at the weakest point. The technical term is a stress concentrator. Any tiny scratch, bubble, or surface imperfection becomes the starting point for a crack. And once a crack starts in glass, there is nothing to stop it. In crystalline materials, a crack meets organized rows of atoms that redirect its path or absorb its energy. Metals can deform plastically, meaning the atoms slide past each other without breaking apart. That is why you can bend a metal spoon without snapping it. Glass cannot deform plastically. Its random structure offers no slip planes for atoms to slide along. So when a crack begins, it accelerates. The energy from the initial impact transfers entirely into crack propagation. A crack in glass can travel at 1,500 meters per second, roughly 3,300 miles per hour. That is faster than the speed of sound in air. The crack branches repeatedly as it moves, which is why glass does not just crack, it explodes into fragments. Engineers have found ways to make glass dramatically stronger by manipulating internal stress. Tempered glass is heated to about 620 degrees Celsius and then rapidly cooled with jets of air. The surface cools and contracts first, creating a layer of compressive stress. The interior cools later and remains in tension. This compressive surface layer acts like armor. Any crack must first overcome the compressive forces before it can propagate. Tempered glass is 4 to 5 times stronger than regular glass. But when it does break, all that stored energy releases at once, causing it to shatter into thousands of small, relatively harmless pebbles instead of sharp shards. Your car side windows are tempered glass. That is why they crumble into cubes when broken. The most advanced glass technology today uses ion exchange rather than thermal tempering. Gorilla Glass, used in nearly every modern smartphone, is submerged in a bath of molten potassium salt at 400 degrees Celsius. Smaller sodium ions in the glass surface are replaced by larger potassium ions, creating even stronger compressive stress. The result is glass that can survive drops from 2 meters onto rough surfaces. The latest generation, Gorilla Glass Victus 2, is the product of over a decade of chemical engineering. But even Gorilla Glass still has the fundamental limitation of being amorphous. It resists scratches and impact far better than regular glass, but apply enough concentrated force and the same principle applies. No crystal structure means no way to stop a crack once it starts. If you found this fascinating, subscribe to Curious Science. Next time, we are exploring why we have different blood types.